Hi everyone, how are you all? Hope you are all fine and enjoying learning. A hearty welcome to Samveda e-learning program. In today's class, we shall learn chapter number 14, the sources of energy from 10th standard science, part 2. This is the first session of the 3 sessions allotted to the chapter. So, let us begin. This chapter is very relevant because the sources of energy is the need of the hour. So, if you are all ready, let us begin. See the picture. In this picture, you can see a farmer plowing and a lady is helping him and the oxes are at work. Look at the picture, another one. Here in this picture, a person is plowing the land with the help of tractor and the birds are flying in search of food. And here a machine which is working at a agriculture field. Oh, look at this picture, a man is working out in gym. Look at this picture, a picture of industry. Industry is at work and there are lots of lights glowing. All these kind of work, they require energy, whether it is man, animal, bird, a machine, a vehicle, whatever, all of them they require energy. What is energy? You know very well, energy is the capacity to do work. And in the picture, you have seen different forms of energy at work. In the first picture, you saw the man plowing. There his muscular energy was at work, and even in the ox the muscular energy was working. And in the next picture you saw the tractor plowing. There petrol or diesel was the energy which is chemical energy, and for the glowing of the lights we use electricity, the electrical energy. All these forms you saw. And you also know the law of conservation of energy, which says energy can neither be created nor be destroyed, but it can be converted or transformed from one form to another. What does it mean? Let us take an example and try to understand this. Look at this picture. Here a boy at some height is jumping. When he climbed the steps and reached some height, he has gained potential energy, and when he jumped into the water, he is converting that potential energy into kinetic energy. So, this is an example, small example of conversion of energy from one form to another. Let us take another example, solar energy, which is very well known source of energy. It is the main source of almost all forms of energy. The plants use this solar energy and prepare their own food in the process of photosynthesis. The stored food is chemical energy. We humans take this energy from the plants in the form of food, and we have our muscular energy. Using this muscular energy, we perform many activities like cycling and all. This is kinetic energy. Children, you have to observe in this picture, in the process of all these things, there is no creation of new energy and no energy is being destroyed. It is only transformation of energy from one form to another. Solar energy to chemical energy, and then muscular energy, and finally kinetic energy. So, this is what law of conservation of energy says. Energy is not created in this process, it is only transformed. So, on the whole, what we can say is the total energy of the universe is constant. Then why do we speak about energy crisis? When the energy is constant, why the question of energy crisis? We speak about power cut and we have slogans, save energy. We say no petrol and we say save fuel also. Why these slogans arise when the energy is constant? To understand this, first of all let us try to understand what is energy crisis. Look at this picture. Overpopulation. Due to overpopulation, we require lot of energy to fulfill their needs, and now it is 7.7 billion the world population, and it is increasing at the rate of 2.5% per year. And look at this urbanization, city lights. You can just imagine how enormous amount of energy is being used to light this city. Look at this traffic jam. Oh, look at the number of cars being jammed on the flyover also. In olden days, car was a luxury. There were only few number of cars. When we were children, if any car comes to a village, all the children used to run behind the car in a joy. But nowadays it is very common. Some families, they have more vehicles than the family members. So, because of that, we are having traffic jams, and to run these vehicles we require energy again. And look at this industrialization. You can have an imagination how much of energy is required to run these industries. Due to all these reasons, due to industrialization and urbanization, the demand of energy is increasing, but the supply is very less. This causes energy crisis. But according to law of conservation of energy, as you know already, total energy of the universe is constant, no creation, no loss. Then why energy crisis? What happened to the energy then? To understand this, we have two examples. Let us look at those examples. Here is a candle. 3 candles are there and they are burning. When they burn, the chemical energy of the candles, it gets converted into light energy, heat energy, and some other products we get. But after some time, the candle burns away and we will be left out with little melted wax. Now the question, can we use all those light energy, heat energy and other products and remaining candle, can we use all of them and prepare new candle, 3 candles again? No, it is not possible. Then where did that energy go? Let us understand with another example. Here we are boiling water with the help of heat energy. We are burning some gas and getting heat energy, and that heat energy is boiling the water. Let us keep this boiled water aside for some time. Then what happens? You know very well, the water gets cooled. The heat energy in the water gets dissipated into the surroundings. Now the question, can we get back that heat energy into the beaker and boil the water? No, it is not possible. To boil the water again, we require some other source of energy, whether it is wood, charcoal or electrical energy or gas, some other energy we require. So that creates the demand. Now I think you understood what is energy crisis. The energy we use to do any kind of work will be dissipated into the surroundings in less usable form. So it can't be used again. This leads to more demand and hence the energy crisis. Experts say there are some political reasons and also the non-uniform distribution of energy sources also reason for the energy crisis. Okay, let it be. And now we have to understand what are the sources of energy, what are the sources which are giving this kind of energy to us to perform our work. The first and most energy source are conventional source of energy. The traditional energy sources are called conventional source of energy. Let me give an example. Wood, charcoal, fossil fuels like coal, petrol and natural gas, wind energy, water energy and biomass are all the examples for conventional energy. Conventional energy means these are the energy sources we are using since long. You know very well, wood and charcoal, the biomass, that means a cow dung or the remains of the plants, were the sources of heat in olden days. Even the coal was used to run the trains and the steam engines. You know very well, wind energy and water energy were used by ancient people to run the windmill and the water mill, to grind the grains. That is why these sources are known as conventional source of energy. Let us try to understand the formation and the usage of fossil fuels in detail. Fossil fuels. What do you mean by fossil fuels? The fuels formed from the remains of dead plants and animals from the past are known as fossil fuels. There are three main fossil fuels. One is coal, another one is petroleum, and the next one is natural gas. All of them are non-renewable sources of energy. That means, once they are used, they get exhausted, they get depleted, and they cause pollution also. So, these energy sources are to be used carefully. Let us see how these fossil fuels are formed, how long it takes for the fossil fuels to get formed. By that knowledge, we can use them carefully. Here is a video with which you can understand the formation of fossil fuels, namely petroleum and natural gas.
What drives our cars, buses and planes, powers our electricity, and allows us to cook our food and heat our water? Most of today's energy needs are met by fossil fuels like coal, oil and gas. These unique, high-energy fuels are non-renewable resources that took millions of years to form. About 2 billion years ago, marine organisms like algae and microscopic animals and plants died and settled on the ocean floor. Beneath other sediments in the ocean, and in the absence of oxygen, these fossils changed into a substance called kerogen. Under heat and pressure, kerogen gradually changes into oil or gas. The whole process usually takes at least 1 million years. At the molecular level, oil and gas are hydrocarbons made up of hydrogen and carbon atoms. The constant pressure and movement of the Earth's crust squeezes oil and gas through the pores or spaces within rocks. Some oil and gas reaches the Earth's surface and seeps out naturally into land or water. Often it is trapped beneath the surface by impermeable layers or rock structures, like faults and folds. Within the crust, oil or gas deposits build up and form reservoirs. Reservoirs are like vast sponges filled with oil and gas. They can be as large as a city. To find oil and gas deposits, geologists use a number of different survey techniques, including seismic surveys, gravitational surveys, and geological mapping. Seismic surveys use reflected sound waves to produce a 3D view of the Earth's interior. New technologies, such as four-dimensional projections and sophisticated graphic renderings of rock structures, are improving the way we find conventional oil and gas deposits. Energy resources that are currently difficult or expensive to extract are called unconventional oil and gas. In a world with limited energy resources, people are looking at more efficient ways of tapping into unconventional oil and gas, or at alternative and renewable sources of energy from biofuels or the sun. What do you think will be the energy sources of the future?
You liked the video very well. Fossil fuels take millions of years to form, but we are using that fossil fuel only to meet our energy needs. Look at the pie chart. Total world energy consumption is met by only the fossil fuels. Nearly 80% of the energy sources are from fossil fuels and only 20% we are using from renewable sources of energy. If we use at this rate, it is going to harm environment. Let us have a look at the rate at which we are using. Here is a beautiful video which gives you an alarm about the rate of use of energy. Hope you liked the video, and therefore, we have to use these sources of energy very carefully, because the petroleum lost in just 53 years and survey says the coal lost in just 110 years. And these fossil fuels, they also cause environmental pollution. Burning of fossil fuels is the reason for greenhouse effect, which increases the problem of global warming. Okay children, but we can't stop using these fuels suddenly. You just imagine a day without electricity and without vehicles. The world will be at halt. We can't stop them using suddenly, but we can go for alternate source of energy. To do that, we should know what are the good sources of energy. Characteristics of a good source of energy. The first and the most characteristic of a good source of energy is it should be easily available and easily accessible. And next one is it should do large amount of work per unit volume or mass. Let me give an example to understand the second point. Here you are looking at two pictures, one is coal and another one is charcoal. Do you know what is charcoal? It is the wood. When we burn the wood with the limited supply of oxygen, we get charcoal. It is carbon. And even the coal is a fossil fuel and it is formed from the plants and from the olden days. All these plants, they buried into the earth's crust, and due to high pressure and temperature and absence of oxygen, they are pressed into coal. When we burn same volume of this coal and charcoal, it is very well known that coal gives more energy. That is why coal is better source of energy compared to charcoal, and that is what we say coal has high calorific value. So, coal has more calorific value compared to charcoal, therefore, coal is a better source of energy. Let us move on to the next point. Characteristics of a good source of energy continued. The third point is easily storable and transportable. should be economic, and that means it should be cheap and it should cause less pollution. Look at this picture. The wooden blocks are stored. You just imagine the space, how large space is taken to store these wood blocks, and just imagine the process of transportation for this. And look at this picture again. Here is a single person holding the cylinder of a gas and is transporting, and now you can compare and have an idea how it is easy to store and transport. Among these two, which one would be the better source of energy? Naturally, the LPG, liquefied petroleum gas, would be the better source of energy. Let us move on to the electric energy. It is having so many qualities of the good source of energy. First, it is easy to store, easy to transport, and easy to convert to different forms. You know very well, when you switch on the light at home, the electric energy is converted into light energy. When you want to heat the water, you switch on the water heater, then electric energy is converted into heat energy. When you switch on the fan, electrical energy is converted into mechanical energy. So, this way electric energy is more useful. Therefore, we are establishing the electric energy power plants near the sources of coal and petrol, and we are using this traditional source of energy to convert that into electrical energy. That we shall discuss in the next class. Now, let us have a quick recapitulation. We learnt energy is the capacity to do work. We learnt law of conservation of energy, that means energy can neither be created nor be destroyed. Energy gets dissipated into the surrounding in unusable form. This causes energy crisis. We learnt that fossil fuels are conventional source of energy and they are non-renewable. They are exhaustible, we learnt, and fossil fuels cause environmental pollution. We learnt this. You can recall now the environmental problems of fossil fuels. They cause global warming, they increase the heat of the globe, and they cause acid rain also, and there are many health hazards are caused by these fossil fuels. Therefore, we have to go for good source of energy, and we learnt characteristics of good source of energy also. These were the learning points of today's class. Let us have a small quiz on what we have learnt so far. Are you all ready? Let us begin. Quiz. The first question: the capacity to do work is energy, force, power, fuel. Recall and answer. Your time starts now. Yes, the right answer is energy. Congratulations. Let us move on to the second question. Which of the following is not an example for fossil fuel? Options are petroleum, coal, wood, and natural gas. Think and answer. Your time starts now. I hope you got the answer. The correct answer is wood. Whereas petroleum, coal and natural gas, they are fossil fuels. Wood is not a fossil fuel. Congratulations. Move on to the third question. Which of the following is not characteristic of a good source of energy? Think of the question. Not a good source of energy. The option: easy availability, less expensive, causing pollution, and large amount of work per unit volume. Think and answer. Time starts now. I hope you got the answer. The correct answer is causing pollution. Easy availability, less expensive, and large amount of work per unit volume, all of them are characteristics of good source of energy, but causing pollution is not a good characteristic. So, move on to the fourth question. The fuel you would prefer to cook food at home is wood, kerosene, LPG, coal. Your time starts. What is your selection? What is your choice? Yes, it is LPG, because it meets many good characteristics of a fuel. Wood, kerosene and coal, they are not environmental friendly and user friendly too. The fifth and the final question: which of the following gives a large amount of energy per unit volume? The options: wood dry, wet wood, coal and charcoal. Your time starts. Did you get the answer? Let us see which is the correct answer. The correct answer is coal. Yes, dry wood, wet wood and charcoal, they have less calorific value, whereas coal, being a fossil fuel full of carbon, has high calorific value, therefore, it gives more energy per unit volume or mass. Congratulations to all of you. Now, as an extended activity, let us do some homework. I hope all of you will do this homework. You can discuss with your teacher, friends, and you can refer some books, you can watch YouTube and answer these questions. The first question: list out any 4 sources of energy you use at home. You can list. This is the activity given in the textbook. Next one: what are the disadvantages of fossil fuels? And third question is: mention the characteristics of a good fuel, an ideal fuel, that means a good fuel. I hope you can do this homework without miss and you can submit to the teacher. And these were the teaching points of this session. In the coming session, that is the second session, we will be discussing about, or we will be learning about thermal power plants, hydroelectric power plants, biomass, wind energy and so on. I hope you will be waiting eagerly to know all this. Thank you for watching. We will meet in the next class. Until then, bye bye. Thank you.